to begin controlled unloading and inspection. At this stage, the banana stems are still fresh from harvest. Their thick outer layers and high natural moisture content make them suitable for fiber extraction. Factory workers inspect the incoming stems to check their condition and overall quality. Only suitable raw material is accepted into the main production line. Forklifts move into position beside the stacked banana stems. They prepare the material for safe and efficient unloading at the receiving zone. The banana stems are lifted from the trucks and placed onto unloading platforms. This ensures the raw material enters the factory in an organized and controlled way. Once unloaded, the stems are arranged neatly in the raw material area. Proper organization at this stage helps maintain a smooth production flow. Transferred by conveyor toward the first processing section. From here, mechanical preparation begins. The stems enter a washing station where high-pressure water removes mud, dirt, and field residue. Clean raw material is essential for better fiber quality. After washing, the stems move along a drainage conveyor while excess water drips away. This prepares them for the next inspection stage. Workers inspect the cleaned stems again under bright factory lighting. This second check ensures only suitable stems move forward into cutting. The selected stems are fed one by one into an automated cutting machine. This machine prepares the raw material for more precise processing. The banana stems are cut into shorter, uniform sections. Cutting them to size makes them easier to handle during splitting and extraction. These cut sections move neatly along the conveyor toward the splitting area. Each section is guided into position for the next operation. An automated machine opens the banana stem sections lengthwise. This exposes the inner layers where the useful fibers are located. Now the wet inner structure of the stem is clearly visible. These fibrous layers will soon pass into the extraction system. Workers place the opened stem sections onto the extraction line. Careful feeding helps the machinery separate the fibers more effectively. The material enters a mechanical decortication machine. Inside, rollers and blades begin separating the fiber from the soft plant tissue. Long banana fibers start emerging from the machine while wet pulp is stripped away. This is the core stage of fiber extraction. Inside the drying tunnel, the fibers move slowly through heated airflow. This controlled drying process prevents damage and improves consistency. As moisture is removed, the fibers become lighter and fluffier. Proper drying is important for both storage and later refinement. Temperature and humidity are monitored throughout the drying process. This helps the factory maintain the correct moisture level in the fibers. A technician checks the fibers as they leave the dryer. This inspection confirms that drying has been completed to the required standard. The dried fibers emerge in a cleaner, lighter, and better separated form. Their texture is now more suitable for grading and finishing. From the dryer, the fibers move by conveyor to the next section. Here, they begin the final stages of refinement and stabilization. The fibers pass through a cooling zone after thermal drying. This allows them to settle before entering the grading system. Spread evenly across the conveyor, the cooled fibers show a pale, natural color and a softer texture. They are now ready for quality separation. A vibrating shaker screen removes dust and tiny leftover particles. This additional cleaning step improves the final fiber purity. The fibers then enter a grading machine that separates them by length and thickness. This helps sort them according to quality and intended use. Longer, premium fibers are directed into one channel, while shorter fibers are separated into others. This classification improves processing efficiency downstream. Overhead sensors scan the fibers for color consistency and purity. Smart monitoring helps maintain a high production standard. Workers at the quality control station examine the fibers under strong white lights. They check appearance, structure, and overall condition. The fibers are also tested by hand for strength and flexibility. This helps confirm whether they meet the required performance level. Approved fibers continue toward further refinement, while rejected short fibers are redirected for secondary industrial use. This reduces waste and supports efficient production. The approved fibers enter a mechanical softening unit. This stage makes the strands more flexible and easier to process. Rotating rollers loosen the fibers and improve their uniformity. The material becomes smoother and less stiff. As the fibers leave the softening unit, they appear more even and refined. A slight natural luster also becomes visible. The softened fibers move into an alignment machine. Parallel guide combs organize them into straighter, more controlled bundles. Through several alignment stages, the strands become neater and more parallel. This improves consistency for finishing and packaging. Now, the fibers move across the conveyor in smooth, continuous sheets. Their improved order makes them easier to handle in bulk. Automated rollers lightly press the aligned fibers into flatter ribbon-like layers. This makes the material easier to control in the next steps. These conditioned fiber ribbons move toward a trimming station. Their edges are prepared for a cleaner and more uniform finish. Precision cutting blades remove stray edges and uneven ends. Trimming improves both appearance and consistency in the finished fiber. The finished fibers pass under bright inspection lights. At this point, the factory checks edge quality, thickness, and general uniformity. Finished fibers are gathered into measured bundles by an automated bundling machine. This creates manageable units for testing and packaging. The aligned fibers are wrapped into compact bundles using clamps and rollers. Tight, even bundling protects the product and improves handling. A worker removes each completed fiber bundle from the line and places it onto an inspection table. This prepares the bundles for final checks. Multiple bundles of refined banana fiber are now arranged neatly in the finishing area. The raw plant material has been transformed into a clean industrial product. The finished fiber bundles enter an advanced quality testing section. Here, their final properties are checked before packaging and shipment. Each bundle is weighed on a digital platform to confirm consistency. Accurate measurement supports standardization and product control. Fiber samples are pulled in a tensile strength machine. This test measures how much force the material can withstand before failure. Technicians also examine the fibers under magnified lighting. This helps detect irregularities in structure, cleanliness, and strand formation. Moisture content is checked using a digital sensor. final moisture balance is important for storage stability and product quality. After testing, the bundles are sorted into premium, standard, and secondary grades. This determines how each batch will be used or sold. Premium grade bundles move onward to the final finishing line. These are the highest value fibers selected for top quality applications. Before packaging, the fibers pass through a final air cleaning tunnel. Loose dust is removed to keep the product clean and market ready. Automated strapping equipment applies binding bands around the bundles. This secures them tightly for packing and transport. A light pressing unit squares the bundles into more uniform shapes. This improves stacking efficiency and presentation. The shaped bundles move toward an automatic wrapping station. The clean packaging zone prepares them for storage and shipment. Robotic arms lift the finished fiber bundles into protective, breathable packaging. This helps preserve product quality during handling. Barcode labels and production tags are added on the labeling line. These labels support traceability throughout the supply chain. Here, the finished fibers begin a second transformation into heavy-duty products. Workers feed the refined fibers into an opening and blending machine. This loosens the material and prepares it for twisting. The fibers pass through a carding machine that combs and aligns them into continuous slivers. This creates a smoother starting form for rope production. Soft, aligned slivers emerge from the carding system in long ribbon-like strands. The material is now more controlled and ready for further preparation. These slivers enter a drawing frame where several strands are blended and stretched evenly. This improves uniformity and helps build rope strength. Next, the drawn fibers move into a roving machine. Here, the material is condensed into thicker, continuous rovings for twisting. The banana fiber roving is wound onto large industrial bobbins. These bobbins will feed the next stage of rope formation. Multiple bobbins are mounted on a creel frame and begin feeding the twisting line. This setup allows several rovings to move forward together. The rovings enter a spinning and twisting machine where the first twist is applied. Loose fibers now start becoming strong yarn-like strands. Under rotating spindles, the twisted yarns become tighter and more stable. Controlled tension is key to building consistent rope structure. Several twisted yarns are then combined into thicker cord strands. This cabling stage increases strength and prepares the material for rope laying. The cord strands are wound onto rotating drums as they build density and structure. At this point, the material is becoming a true industrial component. 3 heavy strands enter a rope-laying machine that twists them together into industrial rope. This is where the final rope body is formed. As the strands twist together under tension, a thick, rugged industrial rope appears. The refined banana fibers have now become a durable, heavy-duty product.